In this video, we will understand what is RxJS and the benefits of using RxJS. I am going to demonstrate the benefit of using RxJS with an example implemented in Angular. The example Angular application is already implemented and it is currently running in the browser. The application displays the live score of FIFA Men's World Cup 2022 final match. This is a match between Argentina and France which was held on 18th December 2022. We are assuming that we are in the middle of the match at the 107th minute. By 107th minute, the score is Argentina 2 and France 2. There is no need to refresh the page to view the updated score. The score is automatically updated by the Angular application every 3 seconds. Let me provide the architecture of this application. This will help you understand how this example works. The file scores.json is the centralized database that contains the live score. Whenever there is a change in match status, this file is updated. The duration property represents how long the match is being played for. The property team1 and team2 contains the playing country name and the number of goals scored so far in the match. The completed property helps to denote if the match is in progress or finished. This data is provided through a mock REST API service. The mock REST API service is launched using JSON server. This service provides the updated score based on the data from scores.json. This is the REST API endpoint of the service which provides the live match score. The REST API endpoint provides the updated score in this JSON format. The Angular application makes the REST API call every 3 seconds to get the match score updates. Hope the explanation so far helps you understand how this example works at a high level. Now I will show the setup details of this application in Visual Studio Code. In Visual Studio Code, this is the Angular application. In one of the terminal, the Angular application is launched using ngserve command. I have already installed JSON server using the npm command. In another terminal window, the JSON server is launched using this command. JSON-server is the command to start the server. In this command, scores.json is provided as the database. The scores.json file is available in the root folder of the Angular application. The --watch option ensures that changes made in scores.json is automatically reloaded. This is the complete setup to run this example. Now I will demonstrate how changes in the match status can be made to reflect in the page. This can be achieved by directly making changes in scores.json and saving the file. Let us assume that we are in the 108th minute of the match. At this point of time, Lionel Messi had scored a goal. Let me update this status in scores.json. I am changing the duration as 108 and changing Argentina's score to 3. In the browser, the duration is currently displayed as 107 and Argentina's score is 2. Once scores.json is saved, after few seconds the updated duration and score should get reflected in the page. Let me now save and check if it works. After a few seconds, we can see duration changed to 108 and Argentina's score changed to 3. The modifications done in scores.json has got reflected in the web page. This means the Angular application is properly refreshing the score every 3 seconds. Another important feature is implemented in this Angular application. The Angular application stops refreshing the data when the match is completed. The completed property in scores.json represents whether the match is finished or not. As long as the match is in progress, completed value should be false. Once the match is completed, the value should be true. Let me now demonstrate that Angular application does not refresh the score after changing the completed property to true. Let me expand the terminal window where the JSON server is running. We can see some logs displayed by the JSON server. I am selecting one of the line in the JSON server log. After some time, we can see the entries getting added. The new entries are getting added every 3 seconds. Each new entry represents the backend REST API call made from the Angular application to get the updated score. Now we will see if the backend calls are stopped when completed is changed to true. In scores.json, I am changing the completed property value as true. I am saving the file. After saving the file, the JSON server gets automatically reloaded. After the JSON server reload, there is one call made from the Angular application. After that, we don't see any further entries getting displayed. This means that the Angular application has stopped sending new requests. This clearly shows that the Angular application contains proper logic to check if the subsequent REST API call should be made or not based on the completed property value sent in each request. If a user leaves the score page open after the match is complete, this logic in the Angular application avoids unnecessary requests made to the server after the match completion. Now that we have understood how the application works, we will walk through the code in the Angular application. In app module, HttpClient module is imported. This helps us to use HttpClient class to make backend calls. The code to display the score is implemented in app component. In app component class, the property score is used to store the live match score. The match score obtained from REST API is stored in score property. This property is used by the HTML template to display the current score. We know that ng-onInit function is called when the Angular application is launched. The ng-onInit function has the code to make the REST API call every 3 seconds. This function also contains the logic to stop making REST API calls when the match has ended. The required logic is implemented in 5 different ways. This part of the code represents the first approach. This part represents second approach. This part represents third approach. This part represents fourth approach. This part represents fifth approach. The getScore, retry and send functions are used by first and second approach. It is sufficient to enable one approach code and comment the rest of them. Enabling any one of the approach makes the backend call to repeat and stops when match is complete. Later in this video, we will have a detailed look into each one of the 5 approaches. In app.component.html, we have the code that displays the match score. Using interpolation, data from score property is obtained and displayed dynamically. In styles.css, appropriate styling and font is defined to give a better look and feel. Hope the explanation provided so far helps you have an overview about the coding done in this example. Now we will have a detailed walkthrough into the code in ng-onInit. This will help us to learn about each one of the 5 approaches used. We will go through each approach one by one. These are the properties of the component which are commonly available for all the approaches. Score contains the updated score data received from the backend. The purpose of interval property will be explained when going through each approach. The endpoint property contains the endpoint URL of the REST API. All the approaches use this property as endpoint when making the backend call. This is the code snippet of the first approach. This approach uses getScore, which is present in the same component class. This approach uses XML HTTP request and built-in JavaScript function setInterval. The setInterval function repeats a given function based on the duration provided. For example, here we are calling the setInterval function. The callback function passed as a parameter will be called every 3 seconds. Here 3 seconds is provided as 3000 milliseconds in the second parameter of the setInterval function. In this approach, first the getScore function gets called. The getScore function creates a new XML HTTP request object. Then the function is defined for onload. The arrow function defined here will be called once data is received from backend. The backend call is initiated when open and send functions are called. After send function is called, the getScore function execution gets completed and the code execution flow returns back to ng-on-init. In parallel, when send function is executed, the REST API call is made in the background and waits for backend response. Before getting the data from backend, the third line in ng-on-init is executed. In this line, using setInterval function, the getScore function is made to be called every 3 seconds. The getScore function is going to be called infinitely till the web page is open. To stop this code repetition, the setInterval is assigned to interval property so that whenever we want to stop the repetition, we can stop it using clearInterval function, for which we can pass this as parameter. At this point of time, the data from backend should have been received. The arrow function defined in onload is called. This line sets the score property with updated score received from backend. The next line checks if the match is ended. If it has ended, it calls the JavaScript built-in function clearInterval, which stops the setInterval. Notice that we are passing the interval property as parameter for this function to denote which function should be stopped. As the interval property is used in different functions, it is defined as a property at the component level. Hope the explanation provided helps you understand how the first approach works. Now we will walk through the code of second approach. In ng-on-init function, a new XML HTTP request object is created. Then the function is defined, which will be called after receiving the data from backend. The send function is called next, which makes the backend call. Once the data is received, the arrow function defined in onload is called. Within this arrow function, the score property gets updated based on the data received from backend. Then from the backend data, we check if the match is completed. If it is not yet completed, we are calling the retry function. The retry function sets a timeout to call the send function after 3 seconds. The timeout is implemented using the built-in setTimeout function available in JavaScript. Once the send function is called, after 3 seconds, the backend response handling arrow function is executed, and this process repeats till the completed property value returned by the backend call is true. Hope this explanation helps you understand how the second approach works. Now we will look into the third approach, which uses fetchAPI promise and setInterval function. In the first line, the fetchScore function is defined. The fetchScore function is called when the second line is executed. In fetchScore function, the built-in fetch function is called. This block of code represents a typical way how fetch makes backend call using then function. When backend call is in progress, in the meantime, the next line gets executed, which initiates the repeated execution of fetchScore function using setInterval. Before fetchScore gets executed after 3 seconds, we would have received the data from backend. Once data is received, the callback function defined in the second then function is called. This callback function sets the updated score. It also clears the repeated backend calls if the match is completed. The fetchScore function is repeatedly called based on setInterval till the match is completed. Hope this explanation helps you understand how the third option works. Next, we will look into the fourth approach that uses XML HTTP request and RxJS observable. In the first line, observable object is created and assigned to a variable named observable. Observable is a class available in RxJS. As parameter of observable constructor, we are passing a callback function. In the second line, subscribe function is called on the observable object created in the first line. This is when the callback function defined as constructor parameter of observable is executed. In this function, XML HTTP request object is created. Then the callback function that needs to be executed after receiving backend data is defined. The backend call is made when open and send functions are executed. When backend data is received, the response data is converted to JavaScript object and provided as next data for observer. Once data is received, the observable is not going to look for any further data, hence the observer is completed in the next line. An observable object in RxJS represents a series of asynchronous data. In this example, the data completes once data is received from backend, after which we are mentioning that there are no further data and completing it using complete function. Once next function is called, it triggers the callback function defined in subscribe function, passing the response JavaScript object parameter of the callback function. The callback function updates the score. The code execution so far displays the score in the page when it is initially loaded. In the next line, we are defining a pipe for the same observable object created in the first line. The pipe function helps to define a delay of 3 seconds. After the delay of 3 seconds, the repeat function makes the callback function in observer object to be called repeatedly. When the repetition should be stopped is defined using takeWhile function, which uses the completed property data received from backend. The pipe function call returns an observable object which is subscribed so that score property can be updated whenever data is obtained from backend. The delay, repeat, and takeWhile functions are available in RxJS library, which are called as operators. These operators help in code repetition and when the code repetition should stop. This is how the fourth approach works. Now we will look into the fifth approach. The HttpClient class is injected through the constructor. The HttpClient class is a built-in class available in Angular framework. This is where we are using HttpClient class in ng on init. In the HttpClient class, we are calling get function passing the endpoint. The get function returns an observable object. In the previous approach, we directly created the observable object, but in this approach, the get function available in HttpClient class creates an observable object and provides it to us. We can see the rest of the code is the same as the previous approach. In a similar fashion, we are using pipe function and the same set of operators to repeat the backend call and make it stop when the match has ended. In summary, we are using the same approach as that of fourth approach, and we are hiding the creation of observable object and XML HTTP request object using HttpClient. Now we will compare and analyze the various approaches. This is the code snippet to make the backend call using XML HTTP request. This is the code snippet to make the backend call using fetch. How to make this code to repeat with delay is the main logic that we need to arrive at. In the first and third approach, setInterval function was used to repeat the backend call. The delay was defined using the second parameter of setInterval function. In the second approach, we used setTimeout function for delay. For repeating the backend call, the functions were called in a cyclic fashion. From onload, the code execution flow goes to retry, then to send, and again onload, which was getting repeated in a cycle. Because of the asynchronous nature of backend call, we were not able to arrive at a straightforward logic to repeat the backend call. Let us now see how this is addressed in approach 4 and 5. In approach 4 and 5, we used built-in functions pipe, delay and repeat from RxJS. In approach 4, we had created observable object from RxJS, which was not required in approach 5. In approach 1, 2 and 3, we had to think and arrive at a code execution flow on how the repetition will happen. In the previous sentence, I would like to emphasize on the word how. We have to explicitly design how code repetition should happen. In approach 4 and 5, we mentioned what we want using delay and repeat function. We did not write any code for delay and repetition. Here I would like to emphasize the word what. We just mentioned what we wanted and we did not write the code on how it should be implemented. The next challenge is to stop the code repetition when the match is completed. In approach 1, 2 and 3, we had to define how this will happen by including an if condition whenever fresh score data is received. In approach 4 and 5, we just included takeWhile function to define when the repetition should stop. The approaches taken in 1, 2 and 3 belongs to imperative programming paradigm. The approaches taken in 4 and 5 belongs to declarative programming paradigm. In imperative programming paradigm, we need to define step by step how the logic should work. In declarative programming paradigm, we just say what is needed and we don't worry about how it should be implemented. Let us have a deep look into programming paradigm. In C programming, a logic with looping needs to be written to find the maximum salary. This is imperative programming. In SQL, the function max of salary will provide the maximum salary. We don't have to write any logic to find the maximum. This is declarative programming. Programming paradigm represents programming feature that requires a complete paradigm shift and thought process when writing code in a specific paradigm. The programming paradigm is broadly classified into imperative and declarative. There are other programming paradigm classifications available under imperative and declarative. I am providing all the classifications and additional details about each programming paradigm. You can pause the video and go through each option, which will help you to get more understanding about each programming paradigm. In this classification, under declarative programming paradigm, we can see reactive programming paradigm. Reactive programming paradigm deals with asynchronous data flows and propagation of change. The objective of reactive programming is to make it easier to handle asynchronous data flow, and it also makes it easier to manage when the change happens which is what was demonstrated in this video using the football match live score example. As reactive programming is not directly supported by JavaScript, RxJS provides a library that makes reactive programming possible in JavaScript. Hence, it is called as Reactive Extensions Library for JavaScript, and RxJS is its short form. If we look into the definition of RxJS in its official website, it mentions that it makes it easier to write asynchronous and callback based code. If we look into the coding approach 4 and 5, we can see that the backend call is completely isolated from what we would like to do after data is received. This part represents getting data from backend, and this part represents the handling of data after getting data from backend. If we look into the coding approach in 1, 2, and 3, the backend call logic and what we will do after receiving the data is mixed up, which makes it difficult to read and manage the code. Hope the explanation provided so far in this video helps you understand what is RxJS and the benefits of using RxJS. One more important point is that based on the example provided in this video, we should not conclude that RxJS is applicable only when we make backend calls. Asynchronous behavior and callback functions are involved when handling DOM events, hence RxJS can also be applied in these scenarios as well. The key takeaway is that when our program gets complex when working with asynchronous behavior and callback function, we should consider using RxJS, which may help to simplify our code. Hope this video provides an entry point to start learning RxJS. Hope this video helps you answer basic RxJS questions in an interview. One more important point to make note of. In this example, 3 seconds was used to reload updated score data, which may not be an ideal refresh duration when working on a real project. Having 3 seconds reload time may put heavy load on the server. 30 seconds or 1 minute can be an ideal refresh duration. I have chosen 3 seconds for this example so that we can see the score change in few seconds. The source code of the live score app demonstrated in this video is available in GitHub. The GitHub URL is displayed in the screen. In the documentation of this GitHub project, you can find the steps to set up and run this app.